Welcome everyone, to Science, to Sleep By. Tonight, I invite you to set aside the noise of the day, to let your mind drift beyond the familiar boundaries of Earth, and to journey with me into a mystery as old as time itself. What if the universe has no end? Imagine a cosmos that stretches forever, a vast ocean of stars and galaxies without edges, without walls, without limits. As you listen, allow these thoughts to quiet your mind, like gentle waves rolling across an infinite shore. This isn't just science, it's a meditation on existence itself, designed to soothe you, to guide you into rest, while filling your imagination with wonder. From the earliest moments of recorded history, human beings have lifted their eyes toward the heavens and wondered how far it all goes. Infinity has always been more than just a mathematical concept, it has been a mirror held up to the human spirit. In ancient Mesopotamia, priests looked upon the night sky and saw no boundary, no wall, only a dome stretching beyond comprehension. To them, the cosmos was a place without end, a great mystery that invited awe and reverence. The Greeks, with their philosophers and mathematicians, began to wrestle with infinity more directly. Zeno of Elea crafted his paradoxes to challenge the mind, forcing it to stumble upon the limits of logic itself when faced with the endless. Later, Aristotle would argue that infinity could never exist in actuality, that it was only a potential, something that lived only in thought. And yet, human imagination resisted this containment. There was always something in us that wanted to reach past the horizon, to touch what lay beyond. As the centuries passed, the fascination with infinity deepened. Medieval scholars found infinity bound up with divinity, describing God as infinite in power and presence. To think about the universe as endless was, for them, to brush against the infinite nature of the divine itself. Mystics often described their visions as journeys into a boundless sea of light, as though the human mind could barely contain even the notion of something without edges. Yet, as much as infinity belonged to theology and philosophy, also took root in the fabric of mathematics and science. The rise of calculus in the hands of Newton and Leibniz in the 17th century depended on the manipulation of infinitesimal quantities, numbers so small that they edged into the infinite in reverse. Infinity became not just a concept for priests and poets, but a working tool for scientists, engineers, and astronomers. But there is something more personal in our endless fascination with the infinite. Consider the way a child gazes into the night sky for the first time, not yet able to name the constellations or to measure the distances between stars, yet sensing intuitively that the darkness above does not stop at the edge of sight. Children ask questions that carry the echo of infinity. What's beyond the stars? And what's beyond that? These questions rarely find a satisfying answer, because every attempt only leads to another beyond. The human mind seems designed to push against boundaries, to wonder what lies past the final frontier, to ask what exists outside of the box, the room, the city, the planet, the galaxy, the universe. This relentless questioning is as much a part of us as our heartbeat. Infinity is not only something we see out there in the cosmos, it is something we feel stirring inside ourselves. Infinity also has a curious dual nature in our psychology. For some, the thought of endlessness brings a sense of wonder and peace, like the vastness of an ocean or the expanse of a desert. It offers perspective, reminding us how small we are in the grand scale of things, and in that smallness, many find comfort. To imagine that the universe stretches on without end is to place our troubles into context, to realize that the anxieties of daily life are tiny ripples against an immeasurable backdrop. But for others, infinity awakens unease, even fear. The thought of something that never stops, that never resolves, can be dizzying, even paralyzing. The German philosopher Immanuel Kant once wrote of the sublime, a feeling that arises when the human mind confronts something so vast it cannot be measured, something that inspires awe and terror at the same time. Infinity is perhaps the most perfect embodiment of the sublime. It overwhelms us, draws us in, yet also reminds us of our limits. The fascination with infinity becomes especially profound when connected with space. Every telescope humanity has built, from Galileo's first simple lenses to the James Webb Space Telescope, has extended our vision deeper into the cosmos. Each advance in observation only multiplies the stars we can see, galaxies we can count, clusters we can map, and every time, the boundary recedes further. We have never reached the edge. We are like sailors on an ocean who, no matter how far they travel, never glimpse land, only more water stretching endlessly outward. Astronomers speak of the observable universe, a sphere some 93 billion light-years in diameter, bounded not by a physical wall, but by the limit of how far light has traveled since the birth of the cosmos. Beyond that horizon lies more. How much more, we cannot say, but the suggestion is always that there is no end, that whatever lies beyond extends and extends forever. Infinity also seeps into our art, into the stories we tell, into the ways we imagine existence. The symbol of the serpent eating its own tail, the Ouroboros, has appeared in cultures across the globe, representing cycles without beginning or end. In modern times, artists like M.K. Escher played with infinity through impossible staircases and tessellated planes that stretch beyond comprehension. Literature echoes with images of infinite libraries, infinite mirrors, infinite dreams. Jorge Luis Borges, the Argentine writer, was captivated by infinity and often wrote of endless labyrinths and books that never ceased in their pages. Infinity fascinates us because it is the ultimate horizon, a place where imagination is forced to expand, where the mind is drawn outward until it can go no further, and even then, it must continue. Yet, for all our exploration, infinity is never fully grasped. We can describe it mathematically, approach it philosophically, even model it cosmologically, but we never quite hold it in our hands. The infinite is always elusive, always receding as we advance. And perhaps that is the root of our fascination. It is not something to be solved, but something to be lived with. It is a reminder that no matter how much knowledge we gather, there will always be mystery. For a species that craves answers, this can be frustrating, but it can also be liberating. To know that there is always more, that the universe may have no end, is to know that the story is never finished, that curiosity will never be exhausted. That wonder will always remain. When we think of the universe, it is tempting to picture it as a vast container, a kind of cosmic box in which all the stars, galaxies, and planets are placed. For much of human history, that is exactly how people imagined it, a fixed stage, and changing, and eternal, where the drama of the cosmos unfolded. But modern science has revealed a picture that is far more dynamic and astonishing. The universe is not a static place. It is expanding, stretching, like an invisible fabric pulled in every direction at once. This discovery not only reshaped our understanding of the cosmos, but also deepened our confrontation with the idea of infinity. For an expanding universe seems to carry no natural limit, no point where the stretching would ever stop. It is not simply a container, it is something alive with motion, growth, and vastness. The realization that the universe is expanding is a relatively recent one. For centuries, philosophers and astronomers imagined a steady, eternal universe that had always existed in its current state. Even Isaac Newton, whose laws of motion and gravity transformed science, pictured a universe that was infinite in size but unchanging in form. But at the beginning of the 20th century, Albert Einstein developed his general theory of relativity, a framework for understanding gravity not as a force but as the curvature of spacetime itself. When he applied his equations to the entire universe, Einstein was puzzled to find that they implied either expansion or contraction. The universe, according to the math, could not simply sit still. Unwilling to accept that, Einstein introduced a term called the cosmological constant, designed to counteract the expansion and hold the universe steady. Later, he would call this adjustment his biggest blunder, because evidence soon emerged that the universe was, in fact, expanding. That evidence came from Edwin Hubble and his careful observations of distant galaxies in the 1920s. Using the most powerful telescopes of the time, Hubble noticed something remarkable. The light from galaxies far away appeared stretched. shifted toward the red end of the spectrum. This redshift was not caused by the galaxies themselves moving through space, but by space itself stretching, carrying the galaxies with it. The farther away a galaxy was, the faster it seemed to recede. This relationship became known as Hubble's law, and it provided the first direct evidence that the universe was expanding in every direction. Suddenly, the cosmos was no longer a static stage, but a growing, dynamic entity, as if the entire fabric of existence were breathing outward. The idea of an expanding universe naturally raises profound questions. If space is stretching in every direction, what is it expanding into? Here the human mind encounters one of its most difficult challenges. We are accustomed to thinking of expansion as something that happens within space. A balloon inflates into the air around it, a ripple spreads across the surface of a pond. But the universe is not expanding into some larger container. Space itself is expanding, carrying galaxies with it. There is no outside into which the cosmos is growing. This is perhaps one of the most difficult ideas to internalize, because it requires us to set aside our everyday intuitions. The universe has no external backdrop, no stage beyond itself. Expansion simply means that the distances between galaxies increase as the fabric of space stretches. And this expansion is not uniform in every detail. While the universe as a whole expands, local structures such as galaxies, solar systems, and planets remain bound together by gravity. The Earth does not grow farther from the Sun, and the Milky Way does not scatter apart. Gravity, at these smaller scales, holds things together firmly. It is only on the largest cosmic scales, where gravity cannot compete with the overall motion of spacetime, that the expansion dominates. Thus, when we look through telescopes and see galaxies drifting apart, what we are witnessing is the large-scale stretching of the universe itself. Over time, astronomers have refined their understanding of this expansion. Measurements of the cosmic microwave background, the faint afterglow of the Big Bang, have allowed scientists to determine not only the age of the universe, but also the rate at which it has expanded across billions of years. At first, many assumed that the expansion would gradually slow down, pulled back by the collective gravity of all matter. Some even imagined that the universe might eventually collapse in on itself, reversing the expansion in a grand contraction often referred to as the Big Crunch. But in the late 20th century, observations of distant supernovae revealed something astonishing. The expansion of the universe is not slowing down, it is accelerating. Some unknown force, dubbed dark energy, appears to be driving galaxies apart faster and faster, as if the very fabric of spacetime has a built-in tendency to push outward. This accelerating expansion adds yet another layer to the mystery of infinity. If the universe were simply expanding at a steady rate, we might imagine that over endless time, it would continue to grow larger and larger, spreading galaxies farther apart. But with acceleration, the picture becomes even more extreme. Galaxies not bound to us by gravity will eventually recede beyond our ability to ever see them, slipping past the cosmic horizon, carried away faster than light can bring their signals to us. From our perspective, the observable universe will grow emptier and lonelier as time passes, with only the galaxies in our local group remaining visible. And yet, beyond what we can see, the universe continues to expand endlessly, stretching farther and farther into realms we can never touch or measure. This vision of expansion connects deeply with the human confrontation with infinity. The idea of a universe that has no end is already overwhelming, but when that universe is actively growing without bound, it invites a kind of vertigo. Expansion suggests that there is no final boundary, no last star, no edge to reach. Instead, space itself keeps generating new vastness. The mind struggles to grasp this, because in our everyday world, everything seems finite. Rooms have walls, journeys have destinations, lives have endings. But the universe, in its expansion, defies this pattern. It is the ultimate frontier, forever receding, never closed. Philosophically, the expanding universe reshapes how we see ourselves. It reminds us that we are not standing at the center of creation, but are instead carried along on a vast tide, participants in a cosmic unfolding larger than anything we can measure. It also reminds us of our limits. No matter how far our telescopes reach, there will always be more beyond, hidden. Not because it does not exist, but because the expansion has swept it beyond our view. We live in a kind of island of visibility, surrounded by an ocean of existence that stretches endlessly outward. And yet, there is something profoundly calming in this thought. To lie back under the stars and imagine that each point of light is drifting gently away on the currents of expansion is to sense the vastness and motion, the universe itself breathing outward. The knowledge that space has no final edge, that it continues to stretch beyond all horizons, can quiet the mind, replacing the noise of daily life with the steady rhythm of cosmic unfolding. In the silence of the night sky, the expansion of the universe is not just a scientific fact, it is a lullaby. A reminder that we are cradled within something immense, mysterious, and without end. When we gaze into the night sky, what we see is not the universe in its entirety, but only a fragment, a small window limited by the laws of physics and the nature of light. The portion that we can observe the galaxies, stars, and cosmic structures that lie within the reach of our telescopes is what scientists call the observable universe. But the word observable is crucial here, because it reminds us that there may be far more beyond, perhaps an endless expanse we will never touch. The difference between the observable universe and the entire universe is not simply a matter of distance, but of perspective, of understanding the boundaries that human perception and technology cannot cross. This idea carries with it both the beauty of discovery and the haunting whisper of limitation, for the observable universe is immense. And yet, it may be just a droplet in an infinite ocean. To understand why the universe is divided into what we can see and what we cannot, we must first think about the nature of light. Light travels at a finite speed, about 186,000 miles per second. While that speed is staggering on human scales, it is not instantaneous when measured against the vastness of the cosmos. When we look at the moon, we see it as it was a little over a second ago, because that is how long it takes for light to travel from the moon to Earth. When we look at the sun, we see it as it was about 8 minutes in the past. As our gaze shifts to distant stars, the delay stretches into years, centuries, and even millennia. Looking across intergalactic space, we are peering millions and billions of years into the past. The observable universe, then, is defined by the distance light has been able to travel since the beginning of the cosmos. The universe is about 13.8 billion years old, which might suggest that we can see out to a radius of 13.8 billion light-years. But because the universe has been expanding as light has traveled, the boundary is much farther away, about 46 billion light-years in every direction. That means the observable universe has a diameter of about 93 billion light-years. This vast bubble is not a physical wall, but a limit of visibility, like a horizon at sea. Beyond it lies more, but we cannot see it, because the light from those regions has not had enough time to reach us. This horizon is sometimes called the cosmic light horizon, and it is one of the most profound concepts in modern cosmology. It is a reminder that what we see is always incomplete, always bounded by time as much as by space. We live in a sphere of knowledge, but outside that sphere may stretch endless realms. This is not a matter of speculation, but of necessity. Unless the universe is strangely small, which all evidence suggests it is not, there must be more beyond our horizon. The galaxies that we can see are not the whole story. They are merely the portion that light has painted across our eyes in the limited span of cosmic history, and yet, even within this observable bubble, the richness of the cosmos is overwhelming. The Hubble Space Telescope has peered into small patches of sky that appear empty to the naked eye, revealing thousands of galaxies in areas no larger than a grain of sand held at arm's length. The James Webb Space Telescope has extended this vision even further, capturing ancient galaxies whose light has traveled nearly the full age of the universe to reach us. These observations remind us of how much detail lies hidden even within what we can observe. The observable universe is not a sparse place, but a teeming expanse of stars, clusters, nebulae, and cosmic webs stretching across billions of light years. And yet, as vast as it is, it may be only the beginning. The distinction between observable and entire universe becomes even more striking when we consider the possibility that the universe has no edge. If the cosmos is infinite, then our observable bubble is like a small illuminated island floating in an unending darkness. No matter how far we stretch our instruments, we will never capture it all, never gather the infinite into finite observation. The thought is humbling and serene. It places human existence into a scale so large that our significance is both diminished and paradoxically elevated. We are small, yes, but we are also conscious beings, capable of contemplating the very limits of perception. Some cosmologists even suggest that what lies beyond the observable universe may be startlingly different from what we see within it. While the laws of physics appear to be uniform across the visible cosmos, we cannot be certain that this uniformity extends beyond our horizon. There may be regions where galaxies are distributed differently, where cosmic structures take on unfamiliar forms, or where the very constants of nature shift. Alternatively, the universe beyond could be essentially the same as what we see here, an endless repetition of galaxies, stretching beyond imagination. Both possibilities confront us with the reality that our perspective is forever partial, that the cosmic whole will always exceed our grasp. The difference between observable and entire universe also leads to fascinating reflections on time. When we see galaxies near the edge of visibility, we are looking billions of years into the past, witnessing them as they were when the universe was young. We cannot see them as they are now, because now, for them, is separated from us by tens of billions of light years of space and time. In that sense, our observable universe is not a snapshot of the present, but a layered history, a cosmic fossil record inscribed in light. The deeper we look, the further back in time we go, until we reach the cosmic microwave background, the faint afterglow of the Big Bang itself. Beyond that, light cannot penetrate, leaving us with a luminous wall that hides what came before. What lies beyond that curtain remains one of the great mysteries of cosmology. From a psychological perspective, the difference between what is observable and what is entire echoes a common human experience. We are always limited in what we can see, always aware that more lies beyond our reach. Just as standing on the shore of an ocean reveals only the waves near the horizon, but hides the depths and continents on the other side, so too does the observable universe reveal only a part of the cosmic whole. To meditate on this is to accept limitation as part of existence. And yet, there is comfort in that acceptance. We are part of a universe so large that it exceeds us completely, and in that vastness lies a kind of peace. For scientists, the observable universe is a laboratory, a place where evidence can be gathered, models tested, and theories refined. For philosophers and dreamers, it is a reminder of what cannot be seen, of what must remain hidden yet real. Both views intertwine, giving us a dual perspective. We are explorers of the known, yet inhabitants of the unknown. Every discovery pushes the boundary of observation outward, but the boundary itself never disappears. There will always be more beyond, always an unreachable realm that invites wonder. To lie beneath the stars and think about the observable universe is to recognize that we live in a cosmic bubble defined by time, by the patient travel of light across space. To imagine the entire universe beyond is to let the mind expand, stretching past the horizon into realms unseen. Together, these two ideas, the observable and the entire, remind us that the universe is both knowable and unknowable, both close and forever distant, both a place of science and of wonder. The question of the universe's shape is one of the most profound and puzzling inquiries in modern cosmology. It is not enough to ask how big the universe is or whether it has an end. We must also ask what form it takes on the largest scales. Is the universe flat, curving outward, or curving inward? Is it like an endless plane, an enormous sphere, or something stranger still? These are not abstract speculations, but deep scientific questions that shape how we think about space, time, and infinity itself. To ask about the curvature of the cosmos is to ask about the geometry of everything. the way space itself is woven, the fundamental architecture of existence. To understand what curvature means in this context, it helps to start with simpler examples. Imagine standing on the surface of the Earth. From our everyday perspective, the ground feels flat beneath our feet, stretching out without curve. But step back far enough, look at images of Earth from space, and you see that what seemed flat is actually curved into a sphere. The curvature is real, but on small scales, it is imperceptible. Similarly, if the universe is curved, its shape might not be noticeable to us on the scale of planets or even galaxies. But across the unimaginable distances of billions of light years, the geometry of the cosmos could reveal itself. There are three main possibilities for the universe's curvature. First, it might be closed, curving inward like the surface of a sphere. In such a universe, if you could travel in a straight line for enough, you might eventually loop back to your starting point, just as a traveler circumnavigating the Earth does. A closed universe has a finite volume, though it has no edge, just as the Earth's surface is finite, but has no boundary. Second, the universe might be open, curving outward like the shape of a saddle. In such a universe, space would expand endlessly, with no possibility of looping back. Finally, the universe might be flat, like a perfectly stretched sheet, extending infinitely without curving in or out. Each of these possibilities carries profound implications for the nature of reality and for the ultimate fate of the cosmos. Einstein's general theory of relativity is central to these questions. It tells us that mass and energy do not merely sit in space, but bend it, shaping its geometry. A star warps the space around it, and a galaxy bends spacetime more dramatically. Extend this principle to the entire cosmos, and the overall shape of the universe depends on its total amount of matter and energy. If there is more matter than a critical threshold, gravity could pull the universe inward, giving it a closed curvature. If there is less matter than that threshold, the universe would be open, curving outward forever. If the amount of matter is exactly at the critical density, the universe would balance perfectly, remaining flat. Thus, the question of curvature is linked directly to the question of cosmic density, how much substance the universe holds. For decades, astronomers have tried to measure this density and the shape of the universe with increasing precision. One of the most powerful tools has been the study of the cosmic microwave background, the faint radiation left over from the Big Bang. This afterglow of creation contains subtle patterns, tiny fluctuations in temperature which can be analyzed to reveal the geometry of space. Observations from missions like the Wilkinson Microwave Anisotropy Probe and the Planck satellite have provided strong evidence that the universe is remarkably close to flat. On the largest scales we can measure, space does not curve noticeably inward or outward. This does not prove that the universe is infinite, but it strongly suggests that it stretches far beyond our observable horizon, potentially without end. The notion of flatness has its own challenges, however. For the universe to appear as flat as it does today, its initial conditions had to be extraordinarily fine-tuned. This puzzle led to the development of the theory of cosmic inflation, which proposes that in the earliest fractions of a second after the Big Bang, the universe underwent a brief but dramatic expansion, inflating at a speed faster than light. This rapid growth would have smoothed out any curvature, leaving behind a universe that appears flat on vast scales. Inflation not only explains flatness, but also accounts for the distribution of galaxies and the structure of the cosmic microwave background. Still, the theory, though widely accepted, remains an area of ongoing exploration, with many details yet to be confirmed. While flatness may be the favored model, the possibility of curvature remains tantalizing. A closed universe, curved inward like a sphere, carries with it the poetic image of a cosmos that is finite yet unbounded. In such a universe, every journey outward would eventually lead back to its origin. The night sky would be like a hall of mirrors, with light from distant galaxies looping around, creating multiple images of the same object. The idea that space might wrap around on itself, that we could in principle see our own galaxy from another direction if we looked far enough, inspires both scientific curiosity and philosophical wonder. An open universe, by contrast, suggests an infinite frontier. In a saddle-shaped geometry, space stretches endlessly in every direction, with no looping, no closure. Such a universe feels closer to the human intuition of infinity, place without walls or boundaries. The open model suggests a cosmos that expands forever, with galaxies drifting apart eternally, never to return. This picture resonates with the accelerating expansion we observe today, driven by dark energy. In this sense, the universe seems to lean toward openness, a geometry without closure, a destiny of endless growth. Yet geometry is not only a scientific matter, it has deep psychological resonance as well. The thought of a closed universe can be comforting, suggesting a wholeness, a self-contained totality where everything connects back to itself. It echoes the cycles of nature, the seasons that return, the orbits that repeat. The open universe, in contrast, evokes a sense of unbounded possibility, of journeys that never end, of horizons that recede forever. Both visions stir the imagination, offering different ways of relating to the infinite. The flat universe, balanced delicately between the two, presents its own calm simplicity, cosmos that stretches like an infinite plane, vast and serene. Thinking about cosmic curvature also reveals how limited our human senses are. We live on a small planet, orbiting an ordinary star, within one galaxy among trillions. Our perception of flatness or curvature is shaped by tiny scales. Just as ancient sailors believed the ocean stretched endlessly until they learned to see the curve of Earth, so too are we sailors on the cosmic sea, trying to discern the bend of space. The fact that we can even approach this question, that we can measure background radiation from nearly 14 billion years ago to infer the shape of the universe, is one of the greatest triumphs of human curiosity. To contemplate the curvature of the cosmos at bedtime is to drift into a meditation on geometry, space, and infinity itself. Imagine lying beneath the stars, wondering whether they stretch across a flat plane, arch along a sphere, or curve outward on a saddle. Imagine traveling in a straight line forever, never reaching an edge, perhaps one day looping back to where you began. Imagine the universe as a great canvas, its geometry written into the fabric of reality, shaping the destiny of everything within it. Whether flat, closed, or open, the universe's shape is not just a scientific fact, but a profound reflection of existence. A question that touches both the mind and the soul. The idea that our universe might not be the only universe has captivated human imagination for centuries. It is a thought that hovers at the edge of science and philosophy, brushing against myth, religion, and speculative fiction, while at the same time finding footholds in modern physics. When we speak of parallel realities or the multiverse, we are not merely telling stories of fantastical worlds. We are entertaining the possibility that existence itself is far stranger and more abundant than we ever imagined. To fall asleep under the weight of this idea is to let the mind wander beyond the limits of our observable cosmos, into a realm where the fabric of reality may branch and multiply, creating worlds upon worlds without end. The seeds of the multiverse concept stretch deep into human culture. Ancient myths often told of layered heavens and hidden worlds, realms that existed alongside our own but beyond ordinary perception. In Hindu cosmology, there are cycles of universes, each born, evolving, and dissolving, only to give rise to another. In Norse mythology, the 9 worlds were connected by the great tree Yggdrasil, each with its own landscapes and beings. Even in Christian theology, the idea of heaven and hell can be seen as parallel realities to our earthly existence. These cultural echoes remind us that the human mind has long been drawn to the thought that our world is not the only one, that reality may contain dimensions beyond the immediately visible. Modern science approaches the idea with its own language and rigor, though the sense of wonder remains. The simplest form of the multiverse emerges from the recognition that the universe may be infinite. If space stretches without end, then beyond the observable bubble we call the visible universe, there may lie regions so distant that light has not yet reached us from them. In those regions, galaxies could form differently, stars could cluster in unfamiliar patterns, planets could dance to other rhythms. And if infinity holds, then every possible arrangement of matter could occur somewhere, repeated endlessly across the boundless expanse. In this vision, parallel realities are not separate dimensions, but far-flung regions of one infinite cosmos, forever beyond our view, yet existing nonetheless. Another doorway into the multiverse comes from the theory of cosmic inflation. Inflation suggests that in the earliest fraction of a second after the Big Bang, the universe underwent an extraordinary expansion, stretching faster than the speed of light. In many versions of the theory, inflation never ended everywhere at once. Instead, some regions stopped inflating, forming bubble-like universes, while inflation continued elsewhere, spawning more and more bubbles. Each bubble could be a universe in its own right, with its own galaxies, stars, and perhaps life. Together, these bubbles form a multiverse, an endless froth of universes within a grander reality. In this view, our universe is only one bubble among countless others, and the totality of existence is a cosmic foam stretching without limit. Quantum physics offers yet another pathway to parallel realities. The mathematics of quantum mechanics allows for particles to exist in multiple states simultaneously until measured or observed. This strange principle, known as superposition, has led some physicists to propose the many worlds interpretation. According to this view, every quantum event with multiple possible outcomes actually branches into parallel realities, with each possibility realized in its own universe. Every decision, every coin flip, every quantum uncertainty spawns a new branch of reality. In one universe, a particle goes left. In another, it goes right. In one world, you chose one path. In another, you chose differently. The multiverse here is not distant in space, but unfolding in parallel, layered realities branching at every moment. These scientific visions of the multiverse vary in detail, but they share a common theme, the recognition that our universe may not be all there is. Whether through infinite space, cosmic bubbles, or quantum branching, the possibility arises that reality is larger, richer, and more diverse than we can imagine. This thought is dizzying, even overwhelming, because it multiplies everything we know. Instead of one cosmos to study, there may be countless. Instead of one history, there may be infinite variations. The human mind, already stretched by the vastness of one universe, must now contend with the idea of unending multiplicity. For many, the multiverse carries philosophical and even existential implications. If there are countless universes, then there may be countless versions of ourselves, living out different choices, inhabiting different worlds. Somewhere perhaps, a version of you chose another career, to another city, loved another person. Somewhere else, a version of you never existed at all. The multiverse suggests that possibility itself is realized, that every path is taken somewhere. This idea can be both comforting and unsettling. Comforting, because it implies that no possibility is truly lost, that everything exists in some branch of reality. Unsettling, because it challenges our sense of uniqueness, our feeling that we are singular beings, living one irreplaceable life. And yet, even with these philosophical ripples, the multiverse remains first and foremost a scientific question. Cosmologists and physicists seek evidence, even indirect, for the existence of realities beyond our own. Some look for subtle imprints in the cosmic microwave background, tiny anomalies that might hint at collisions between our universe and others. Others explore the mathematics of string theory, which suggests that there may be multiple dimensions of space, far beyond the three we perceive, each giving rise to its own universe with its own physical laws. Still others probe the mysteries of dark energy and dark matter, wondering if they are hints of interactions with unseen realities. The search is challenging, because by definition, parallel universes may be forever beyond our reach. But the pursuit itself is a testament to human curiosity, a refusal to accept boundaries without exploration. From the perspective of bedtime reflection, the multiverse is both a scientific possibility and a meditation on infinity. To lie in the dark and imagine not only our universe, but countless others, is to let the mind drift into unbounded wonder. Picture universes bubbling into existence like foam on an endless sea, each with its own stars and skies. Picture realities branching at every moment, like the countless twigs of a tree spreading into eternity. Picture galaxies stretching beyond our horizon, not as the end of space, but as the beginning of something larger still. These images quiet the noise of everyday life, replacing it with visions of endless possibility, where existence itself has no boundary. The multiverse also reminds us of humility. For all our advances, for all our measurements and theories, we remain at the beginning of understanding. We live in one universe, one bubble, one branch, and from that limited vantage, we try to infer the whole. Whether or not parallel realities exist, the very act of considering them enlarges our imagination, stretching our minds to match the grandeur of the cosmos. It is a reminder that the universe is not merely what we can see, but also what we can dream, what we can hypothesize, what we can wonder about in the stillness of night. In the end, the possibility of parallel realities is not just a scientific hypothesis, but a mirror to our own longing for more understanding, more discovery, more connection to the infinite. It is the whisper that says, what you see is not all there is. Beyond the horizon, beyond the edges of comprehension, reality may continue in ways unending, multiplying itself into shapes and forms we cannot yet imagine. To think of this as you drift to sleep is to let your mind float beyond one universe, into many, into the possibility that existence is not singular, but endlessly branching, endlessly unfolding, endlessly vast. The concept of infinity has always pressed against the edges of human perception. Our minds, shaped by finite lifespans and bounded experiences, instinctively measure and define things with limits. We count days, years, distances, and even lifetimes. We measure oceans, weigh mountains, and chart stars, always seeking boundaries that can be drawn and understood. But when faced with infinity, the human mind enters unfamiliar territory, a landscape without edges or endpoints. The thought of something that has no end, no border, no conclusion, challenges the very structure of our thinking, and in that challenge lies both wonder and unease. Infinity appears in many forms, and long before it was a subject of modern science, it was a subject of philosophy and mathematics. The ancient Greeks wrestled with it as a paradox. Zeno's paradoxes, for instance, showed how dividing time and space into smaller and smaller parts leads to infinite regress, a puzzle that suggested motion itself might be an illusion. Aristotle, though fascinated, resisted the notion of actual infinity, preferring to see infinity as something potential rather than real, a process of never-ending continuation rather than a completed reality. Even then, the human mind hesitated before the abyss of endlessness, unsure how to accept a concept so alien to everyday experience. Mathematics eventually gave humanity a firmer grasp on infinity, though never complete mastery. The symbol became a way to capture the idea of endlessness in a finite stroke of ink. Calculus, developed by Newton and Leibniz, embraced infinity as a tool, using infinitely small steps to describe motion and change with astonishing precision. Later, the mathematician Georg Cantor expanded the concept dramatically, showing that not all infinities are equal, that some are larger than others. His work revealed a hierarchy of infinities, each more vast than the last, stretching far beyond what human intuition could easily grasp. Cantor himself was said to have struggled with the weight of these discoveries, as though the confrontation with infinity was not merely intellectual but deeply existential. Science, too, has forced us to reckon with infinity in new ways. In cosmology, the possibility that space is infinite places us in a universe without boundaries. If the universe has no end, then there are not just countless galaxies, but truly unending galaxies, stretching forever. If time itself is infinite, then there was never a beginning, and there will never be an end, only cycles without origin or conclusion. These scientific possibilities are not easy for the human mind to hold. Our brains evolved to navigate forests, rivers, and skies, worlds with edges, seasons, and cycles. To contemplate infinity is to stretch a mental tool beyond its usual capacity, like trying to capture an ocean with a single cup. And yet, infinity is not merely a scientific abstraction. It touches human imagination, spirituality, and art in profound ways. Poets have written of eternal love, philosophers of the infinite mind, theologians of infinite divinity. The infinite often becomes a symbol of the sacred, a way to gesture toward that which transcends human limits. In Christian theology, God is infinite, without beginning or end, beyond measure or comprehension. In Buddhism, cycles of rebirth suggest an unending process of existence. In Islamic thought, the infinite nature of Allah is beyond all human conception. Across cultures, infinity becomes the language of transcendence, the attempt to articulate what cannot be contained. For the individual, infinity can evoke both awe and fear. To think of infinity as vastness, an endless ocean of stars, an unending expanse of time, can be humbling and calming, a reminder that human concerns are but ripples on the surface of eternity. At the same time, the very same thought can provoke dread, a sense of being lost in something immeasurable, of vanishing into an expanse with no landmarks, no anchor, no end. Psychologists have noted that when people dwell deeply on the idea of eternity or boundlessness, some feel comfort while others feel vertigo. Infinity is not neutral. It is an emotional landscape as much as an intellectual one. Part of the difficulty lies in the human tendency to imagine infinity in terms of what is familiar. We try to picture an endless road, an endless sequence of numbers, an endless sky. But any image we create is limited, for our imagination always frames infinity as a finite thing extended beyond its natural borders. Infinity is not just a lot or bigger than big. It is a category of its own, an existence without conclusion. That is why it slips through the fingers of thought, why it remains a mystery even when surrounded by equations and theories. At night, when the world grows quiet and thoughts slow down, infinity takes on a new role. In the stillness of lying down and looking up at the dark ceiling or the stars beyond it, infinity becomes a meditation. The thought that space has no end, that time may stretch forever, can soothe the restless mind by placing it in a context so large that personal worries dissolve. A missed opportunity, a harsh word, a passing frustration, what do these mean against the backdrop of infinity? The mind softens, letting go of its tight grip on small concerns, and instead drifts outward, into the endless expanse of what is. This is why infinity is such a powerful theme in science to sleep by. It is not just an abstract idea, but a portal to calmness, to a state where human life is recognized as part of something immeasurable and unbounded. Children often ask questions that touch on infinity, because their minds are fresh to wonder. A child might ask, what is beyond the edge of space? Or, what happened before the beginning? Or, if numbers never stop, does that mean they go on forever? These simple, profound questions remind us that infinity is not only the realm of advanced thinkers, but part of natural human curiosity. The difference between a child's question and a philosopher's speculation is not the wonder itself, but the words used to express it. Infinity is the meeting ground of innocence and genius, where curiosity collides with the impossible to comprehend. Technology and science fiction have also played with human perceptions of infinity. Writers imagine endless universes, infinite timelines, and immortal beings. Movies and books create stories of time loops that never end, or dimensions that multiply without limit. These stories give us a way to taste infinity, to step into it for a while without being overwhelmed. They help us practice imagining the unimaginable, and in doing so, they prepare our minds for the vast possibilities suggested by real science. Infinity becomes less frightening when we can play with it in imagination, when we can weave it into narrative and art. In the end, human perception of infinity is not static. As our science deepens, our philosophies evolve, and our imaginations stretch, we slowly expand the mental tools we use to grasp the infinite. Each generation pushes a little further, adding nuance, equations, metaphors, and images. Yet the essence remains elusive, because infinity is by its very nature beyond capture. Our perception of it is like standing at the shore of a vast sea at night. We cannot see its end. We cannot know its depths, but we can feel its presence, sense its immensity, and allow it to shape our thoughts. To live with infinity is to accept both its strangeness and its beauty, to let it remind us that reality is larger than the mind can contain, and that the journey of understanding is itself, without end. The cosmic horizon is one of the most profound ideas in modern cosmology, a boundary not made of walls or edges, but of light, time, and the speed at which the universe expands. It represents the farthest distance we can see into the cosmos, the limit of our observable universe. Beyond this horizon, light has not yet had enough time to reach us since the birth of the universe, which we mark as the Big Bang nearly 13.8 billion years ago. This horizon does not mean the universe stops at that point. Instead, it is more like standing on a shore and looking out over the ocean, where the horizon line appears as the edge of sight. Though the water continues far beyond what the eye can see, our observable universe stretches about 46 billion light-years in every direction, making it a sphere with a diameter of roughly 93 billion light-years. The vastness of this sphere is staggering, holding hundreds of billions of galaxies, each with hundreds of billions of stars, many of which likely host planets of their own. Yet this observable universe is only the part of reality we can access with light, telescopes, and measurement. It is not the entirety of the cosmos. Just as standing on Earth's surface does not allow us to see the entire planet, standing at one point in the universe does not allow us to see all of existence. The idea of the cosmic horizon is tied closely to the finite speed of light and the finite age of the universe. Light travels incredibly fast, about 186,000 miles per second, but even at that unimaginable speed, it takes time to cross great distances. A photon from the sun takes about 8 minutes to reach Earth. A photon from the nearest star outside our solar system takes more than 4 years. And light from galaxies near the edge of our observable universe has been traveling for billions of years, carrying with it an ancient snapshot of what those galaxies looked like long before Earth even formed. The cosmic horizon, therefore, is not just a spatial boundary, but also a temporal one. Looking deeper into space means looking deeper into time, until we reach the faint glow of the cosmic microwave background, the afterglow of the Big Bang itself. Yet the most fascinating aspect of the cosmic horizon is what lies beyond it. Cosmologists widely believe that the universe does not end at the observable limit. Instead, it extends much further, perhaps infinitely, in directions we cannot see. The expansion of space itself carries distant galaxies away from us so quickly that their light will never reach us, no matter how long we wait. These regions are beyond our horizon forever, locked away from our observation, not by walls, but by the laws of physics themselves. The thought that entire galaxies, stars, and perhaps civilizations exist beyond our reach is one of the most humbling ideas in science. It reminds us that our cosmic view, vast as it seems, may be only a sliver of what exists. The horizon also changes with time. In the early universe, only a small portion of space was visible, since light had not traveled far. As the universe aged, more and more became visible. Even now, the observable universe continues to grow as light from more distant regions finally reaches us. But at the same time, cosmic expansion is accelerating, driven by the mysterious force we call dark energy. This acceleration means that many galaxies are being carried away faster than the speed of light relative to us. Not because they are moving through space, but because space itself is stretching. These galaxies will slip beyond our cosmic horizon, becoming forever invisible. Future astronomers, trillions of years from now, may see only their local galaxy cluster and nothing beyond, their horizon shrunken to a lonely island in an endless dark sea. The cosmic horizon has deep implications for our understanding of reality. It suggests that the universe we can study is only a part of a larger whole, a fraction of what exists. This aligns with the idea that human perception and knowledge are inherently limited, not by lack of effort, but by fundamental physics. It may be impossible, in principle, to ever see beyond the horizon, no matter how advanced our technology becomes. The horizon is a cosmic curtain, hiding vast stretches of reality from our view. For philosophers and scientists alike, this raises questions about the nature of knowledge. If we cannot see beyond the horizon, can we ever truly know the full universe? Or are we destined to live within our observable sphere, forever speculating about the unseen beyond? The concept of the cosmic horizon also connects to the idea of infinity. If space does stretch on without end, then what lies beyond our horizon could be endless galaxies and structures, repeating in every direction without limit. Some cosmologists even suggest that beyond the horizon, regions of space may look dramatically different. The physical constants that govern our universe, the strength of gravity, the charge of the electron, the speed of light might vary in other regions, giving rise to universes with different properties. In that case, our horizon is not just a boundary of distance, but a boundary of familiarity, beyond which reality itself may take unfamiliar shapes. On a more personal level, the cosmic horizon reshapes how we view our place in existence. It shows us that our perspective is not absolute, but limited, that what we know is framed by what we can observe. Just as ancient sailors once believed the horizon at sea was the edge of the world, we may now be standing at the edge of a far greater ocean. The horizon reminds us that humility is essential in science, that certainty must always be tempered by awareness of the unknown. At night, when we gaze at the stars, the cosmic horizon becomes more than a scientific concept. It becomes a meditation. Every point of light in the sky is a messenger from the past, some from nearby stars, others from galaxies millions of light years away. Each photon carries a story across time, converging on our eyes and telescopes, whispering of distances we can scarcely imagine. And beyond those whispers lies a silence, the vast unseen beyond the horizon, where light has not yet, and may never, arrive. To contemplate this as you drift into sleep is to place yourself at the boundary of the known and the unknown, to rest in the thought that reality stretches beyond your sight, vast and unending. The cosmic horizon is both a limit and an invitation. It limits what we can observe, but it invites us to imagine what might lie beyond. It is a reminder that science is not about having all the answers, but about continuing to ask questions, even when answers are hidden. Beyond the horizon, there may be endless galaxies, endless worlds, endless possibilities. The boundary of sight becomes the boundary of wonder, and the human mind, though limited, stretches outward to meet it. In this stretching lies the beauty of our search. We cannot see the whole, but we can imagine it, and in imagining, we expand the horizon within ourselves. To live in a universe that might have no end is to live in the midst of an unanswered question, a mystery that does not dissolve no matter how far our knowledge advances. Humans are, by nature, seekers of answers. We look to the stars, to the oceans, to the cells and atoms within us, and we ask why and how. Yet when it comes to the possibility of an infinite cosmos, the question becomes too large for tidy conclusions. What does it mean for us, for our lives, for our sense of purpose, to inhabit a reality without boundaries? How do we live, not only with what we know, but with the immensity of what we cannot know? Mystery has always been part of the human experience. For early humans, the night sky itself was an unending riddle. The constellations told stories, the wandering planets stirred curiosity, and the vastness of the heavens inspired both reverence and fear. Over time, science has pulled back many layers of that mystery, showing us that stars are suns, that galaxies are vast collections of stars, and that the universe itself has a history that began nearly 14 billion years ago. Yet even as we uncover these truths, new mysteries emerge, often larger and more profound than the ones before. Dark matter and dark energy, for example, make up most of the universe, yet remain almost entirely unknown. The horizon of knowledge expands, but so too does the horizon of mystery. Living with the mystery of a possibly endless universe requires a certain balance. On one hand, mystery fuels our curiosity. It drives science forward, inspires philosophy, and sparks imagination. Without unanswered questions, discovery would come to a halt, and the sense of wonder that animates human creativity would wither. On the other hand, mystery also requires acceptance. Not every question will have a final answer, at least not within the reach of human minds. To live with mystery is to live with humility, to recognize that our role may not be to solve everything but to participate in the act of seeking, to explore without demanding completion. The thought of infinity brings this balance into focus. If the universe has no end, then there may be no final destination of knowledge, no ultimate boundary we can point to and say, "This is where it stops." Our journey, then, is not toward an ending but through a process, an endless unfolding of understanding. In this sense, living with mystery is like walking a path that stretches into the horizon. We may never reach the horizon, but the act of walking shapes us, expands us, and gives meaning to the journey. Science, philosophy, and art become not just ways of solving puzzles, but ways of living meaningfully in a world that refuses to be fully contained. Mystery also has a calming aspect when viewed from a personal perspective. Everyday life is filled with questions, many of them pressing. What will happen tomorrow? What choices should I make? How do I navigate uncertainty? Against this backdrop, the mystery of the infinite cosmos places things in perspective. Our personal uncertainties, while real and important, are set against a backdrop of unanswerable cosmic questions. The thought that the universe may have no end makes our daily concerns feel smaller, less overwhelming. It is not that they vanish, but they soften, taking their place within a larger whole. This perspective can be deeply calming, especially at night, when the mind drifts and sleep approaches. Living with the mystery of infinity also challenges the human sense of control. We often like to believe that we can master our environment, predict outcomes, and chart clear courses through life. But the infinite cosmos reminds us that control is limited, that we are part of something vast beyond our grasp. This can feel unsettling, but it can also bring liberation. If the universe itself is without end, then perhaps it is not our role to control but to participate, to witness, to engage with wonder rather than mastery. Mystery becomes not an obstacle but a companion, a reminder that life is richer when we do not demand total clarity. For some, the thought of an infinite universe touches on spirituality. Infinity, as an idea, has often been linked to the divine, to the transcendent, to that which lies beyond human reach. In many traditions, living with mystery is seen not as a failure, but as a form of wisdom. To recognize the limits of knowledge, to bow before the vastness of what is unknown, is to take a posture of reverence toward existence itself. In this way, the scientific mystery of an endless cosmos and the spiritual mystery of ultimate reality may converge, both pointing to the humility and awe that arise when faced with what cannot be fully explained at the same time. Living with mystery does not mean abandoning reason or inquiry. It does not mean giving up the search. Quite the opposite. The presence of mystery makes the search all the more meaningful. The recognition that we may never reach an endpoint does not diminish the value of each step forward. Every discovery, no matter how small, expands the circle of light in the midst of the unknown. Every question answered deepens the mystery, but it also deepens our participation in the universe's unfolding story. To live with mystery, then, is to live as both seeker and dreamer, scientist and poet, questioner and contemplator. In everyday life, embracing mystery can also shape how we relate to one another. Just as the universe cannot be fully known, so too each person holds depths that cannot be entirely measured. When we accept mystery in the cosmos, we may also learn to accept it in others, respecting the complexity of human lives that cannot be reduced to simple explanations. The infinite universe becomes a metaphor for the infinite depths of human experience, each person a cosmos of their own, full of hidden galaxies of thought and emotion. As night falls, and the mind prepares for rest, living with the mystery of an endless universe can become part of a bedtime meditation. Instead of wrestling with the need for closure or final answers, one can let go into the vastness, allowing the unanswered to remain unanswered. The thought that the universe stretches on without end, that existence itself is mystery, becomes not a source of anxiety, but a lullaby of sorts, an invitation to rest in the unknown. In this way, science to sleep by is not only about facts and theories, but about the art of dwelling in wonder, of letting the infinite calm the finite mind. Mystery is not the absence of knowledge. It is the presence of something greater than knowledge. To live with it is to live with openness, curiosity, humility, and awe. In the face of an endless universe, the most profound response may not be to demand answers, but to marvel at the fact that such questions exist at all. To rest in that marvel is to live fully in the mystery. To accept that we are part of a reality that stretches beyond our comprehension, and to find peace in knowing that the unknown is not an enemy, but an essential part of existence itself. As we drift through these reflections on what it might mean if the universe has no end, we find ourselves caught between the known and the unknown, between the measurable and the immeasurable. Science gives us remarkable tools to explore, from the mathematics of infinity to the theories of cosmic expansion and the tantalizing possibility of a multiverse. Philosophy and imagination add depth, reminding us that mystery is not merely a gap in knowledge, but a space for wonder. Spirituality whispers that infinity has always been part of how humans reach for the transcendent. Together, these perspectives do not resolve the question of whether the universe truly has an end, but they weave a tapestry of meaning around it. The observable cosmos, with its horizon set by the speed of light, shows us a grand stage of galaxies and stars. Yet even this immensity may be only a fraction of reality. Beyond that horizon, perhaps forever hid, lie regions that may stretch without limit, variations of existence we cannot yet fathom. And if the universe is infinite, then every path of possibility might exist somewhere. Every arrangement of matter realized, every star mirrored endlessly in the silence of space. For us, finite beings with finite minds, the thought of an infinite cosmos is both humbling and liberating. It shrinks our worries, reminding us that our lives are small threads in a vast, unending fabric. Yet it also enlarges our sense of belonging, placing us within something so immense that mystery itself becomes a companion. To live with the idea of an endless universe is not to solve it, but to let it shape us, to accept that wonder is more enduring than certainty, and that questions are sometimes more beautiful than answers. As you lay your head to rest and let your thoughts drift outward, imagine yourself floating at the edge of the cosmic horizon, peering into the vastness that stretches beyond sight. Let the silence of infinity calm your mind, and let the mystery of the unending cosmos cradle you into sleep, carrying you gently into dreams where boundaries dissolve and the universe continues on, without end.